Okay, this section is about the mean value theorem. Let me explain first graphically what it means, and then we'll talk about the definition here. So you're going to make a note card on this box right here. Basically what it says is if you have a continuous function on a closed interval, so you have a function that has no corners or cusps or holes in between, so this is continuous and differentiable, there exists a number c such that the derivative, or the instantaneous rate of change, is equal to your average rate of change. Okay? So remember, this right side is just a formula for the slope of the secant line. This is your average rate of change. So that would be the slope between 2 points right here, A and B. This side is your derivative, which is your instantaneous rate of change, which is another word for the slope of the tangent line. So if you notice, right here, there is a tangent line that has the same slope as this secant line that we drew. So what we're trying to figure out is this value c is where that occurs. Okay? So let's do it graphically first also, and then we'll do it algebraically. So I notice that this is a continuous and differentiable function. It says find the value of c in the interval 1 to 5 that satisfy the mean value theorem. So let's do it graphically first. So 1, 5. So this would be the secant line. So that would be the right side of this equation right here. If I look just graphically, it looks like, okay, somewhere around here, there's a place where I can draw a tangent line that looks like it has the same slope. So that would be this side. So, and it looks like it's about 2 point, maybe 2, a little bit less than that, or 2.4. Now, algebraically, this is the way we're going to do it. Okay, so I need the derivative because that's the left side. So my derivative is going to be, the root of 3 is 0. So bring down the negative 1, reduce the power by 1 is x to the negative 2, so it's 5 over x squared. Your f of b minus f of a over b minus 1 will be f of 5 minus f of 1 over 5 minus 1. So the mean value theorem from up here says there's a place where these two things are equal. So there's a place where 5 over x squared is equal to, if you plug in 5 here, you're going to get 3 minus 1, which is 2. If we plug in 1, okay, which is negative 2, so you'll get 1 for this whole piece. So this ends up being 4 over 4, which is 1. If I solve it, cross multiply, you get x equals plus or minus square root of 5. And if you notice, I'm only looking for numbers between 1 and 5, so I don't care about the negative value. So square root of 5 is approximately 2.24, which is what I'm looking at graphically. Okay? Let's look at this next function here. So before you start using the mean value theorem, you want to check that the conditions are true. So first of all, is it continuous on that interval? Yes, I can plug in any number between negative 1 to 1. I can square it, I can take the cube root of it, so it's continuous. To check if it's differentiable, you're going to go ahead and take the derivative. So your derivative is 2/3 x to the negative 1/3. I'm going to drop it here. This is your derivative. Notice the derivative does not exist at x equals 0. There's really a cusp there. So at x equals 0, it is not differentiable. So it is not differentiable in this interval, so mean value theorem does not apply. So we cannot use the mean value theorem. Okay, let's look at a couple more graphically. So we're going to draw a secant line between negative 2 and 1. Here's negative 2, and here's 1, and here's my secant line. So the question on these problems is, how many values of x satisfy the condition of the mean value theorem? Well, this is a smooth curve, so I know it's continuous and differentiable. So it looks like somewhere over here I can draw a tangent line. So I would say one place, how many values, where the slope of the secant line is the same as the slope of the tangent line. Okay, let's try the next one. Negative 2 is here, 0 is here. So there's my secant line. So how many places does it look like there's a tangent line with the same slope? I would say I can probably draw a tangent line here that has the same slope, and it looks like somewhere down here there's another place with the same slope. So I would say 2 places where the slope of the secant is equal to the slope of the tangent. Okay? This one here, this is not differentiable at negative 1, which is the interval I'm looking at, so the mean value theorem does not apply. Okay. let's look at a couple more problems doing it algebraically. So I want you to apply the mean value theorem, if you can, and then find the value of c. So this is a polynomial. Any polynomials will be differentiable and continuous everywhere because it's a smooth continuous curve. So conditions are met. Now, I need the derivative, which is 2x. I also need to find f of 2 minus f of negative 1 over 2 minus negative 1. So f of 2 is 4, f of negative 1 is 1, so 3 over 3, this gives me 1. So I'm going to set these two equal to each other. So there's a place where the derivative is equal to the average rate of change, and that place where that occurs is exactly at x equals 1/2. Okay, let's try number 6. So I'm only looking from 1/2 to 2. I can plug in any number from 1/2 to 2. So this is continuous. To check if it's differentiable, I need the derivative. So we're going to use the quotient rule. So the derivative of the top is 1 times the bottom, minus the derivative of the bottom is 1 times the top, all over denominator squared. So if I simplify this, x's drop out, I'll have negative 2 over x squared. So if I notice, the only place where the derivative does not exist is at x equals 0. But 0 is not in my interval, so it is differentiable on this interval, so I'm fine. So I need to find f of 2 minus f of 1/2 over 2 minus 1/2. And if you do that, algebraic, use your calculator if you need to, you should get negative 2. So there's a place where the derivative is equal to the average rate of change. Cross multiply, solve it however you need to. You get x equals plus or minus 1. But make sure your answer is in the interval. So the only value that is in that interval is x equals 1.